Assalamu alaikum. So, of the theory parts, we have come up with a lot of theories. We have done part two. The part one and the part two. Both of them are done with the theory parts. Now we have two more theories that we have to learn when it comes to simple harmonic motion. So once we're done with that, we will come on to our conclusion and whatnot, so we can move on to problems and all these kinds of things, right? So there are two more theories in simple harmonic motion. One is the Hooke's law, right? Hooke's law, and the other one is the the formula that x squared is equal to omega squared into the bracket of a squared minus x squared. So these are the two things that we are going to learn today, right? So most of the times, right, advanced level students always try and get a problem whenever they have a kind of a string which is hanging, and then it oscillates up and down. So this is the main kind of question they used to ask every time, right? In some cases, in some instances, they might ask some kind of a spring and then it goes up and down, as we have seen in the first video. And then sometimes, right, in case they may ask horizontal simple harmonic motion as well, right? So these are three kinds of simple harmonic motion that have been appeared so far in the advanced level combined mathematics question. And furthermore, one essay question will be there, for sure, in applied mathematics part, right? So it's always better to prepare for simple harmonic motion, since this is the easiest section, one of the easiest section in the advanced level applied mathematics paper. All right. So Hooke's law. So what this Hooke's law means? When you have a string, so let us draw a string like this, and this is the natural length of the string, and if you tie a mass, what is going to happen? Due to the mass, since it is an elastic string, since this is an elastic string, this is going to come down. So how is that going to happen? From this position, it's going to come to somewhere else here, and this is called the equilibrium position. So at the equilibrium position, we say that x is equal to 0, right? Usually we say x is equal to 0, right? It shouldn't be, always it's not the case, but most of the times we say x is equal to 0, right? Now, you might have an extension of E when you have the mass. This is the natural length. When you tie the mass, you have an extension. So this is going to be the mass or the weight mg. Due to the mg weight, you are going to have a tension. So if I want to apply Hooke's law, Hooke's law says that the tension is equal to some kind of a constant times the extension divided by the natural length, right? So if I want to apply F equal to ma, or forces, upward forces balances downward forces, mg is going to be equal to T. But T according to Hooke's law, Hooke says that there is some constant called lambda, and this tension is directly proportional to this lambda, and the extension and inversely proportional to the natural length. So he says that lambda E over T lambda E over L is equal to T. So this is Hooke's law, and this lambda is called as the modulus of elasticity, right? Furthermore, now lambda E over L, now E is the extension and L is the natural length. The other theory part is that, x dot whole thing squared is equal to omega squared a squared minus x squared. So x dot squared, what does this x dot squared actually means? X dot is the velocity of the particle. So when the particle moves, when it oscillates, it has a kind of a velocity that you have to understand very carefully. Right. Whenever we look at the string, the string is going to oscillate up and down. So at any position it's going to have velocity, except for the amplitude, when it reaches the amplitude, right? So when the x is equal to amplitude, when x is equal to a, right, x dot or the the velocity is going to be 0. At any other position, you have the velocity. When x is equal to 0, a squared omega squared, this attains the maximum value. When this is 0, this attains the maximum value. So x is the equilibrium position. So this is the next theory part of our simple harmonic motion, right? So we conclude with at amplitudes x dot equal to 0, right? And at the equilibrium position, x dot is maximum. So these are the two main theory parts that we are supposed to do, and we are done with that. And we will meet by the next video with an advanced level question. Probably I might think, I'm thinking of doing the 2011 advanced level paper.